So, good morning, students.
Good morning, sir.
Good morning, Sai Krishna. Uh, Now, let us quickly look at what we have seen in the last class. In the last class, we have started the unit 2. In unit 2, we have started the homogeneous slabs. Homogeneous slabs we have started. These homogeneous slabs are taken as a composite slab or composite wall example. So all these are same words. In this, first we have seen the electrical analogy. In this electrical analogy, we have seen that there is a potential difference. Analogous to potential difference, we have temperature difference here. In electrical thing, we have current flowing, we have heat flowing here. So because of these, there is a resistance arising in your electrical circuit. The same thing we have taken here, and we have said that the resistance is thermal here, and we have taken it in form of delta T by Q. And the thermal resistance is taken like this. The thermal resistance is taken delta T by Q is equal to L by Ka is what is taken. And then the unit we have seen, it is Kelvin per part for thermal resistance. See, what is the use of this thermal resistance? That is the important thing. The use of the thermal resistance is that you can convert any given problem into a resistance circuit. That is your electrical circuit. Either it is in a resistance in series or resistance in a parallel, you can convert. Once you can convert, what you can do is you can solve it like a electrical circuit. As you solve your electrical circuit in terms of resistances, same way here also the resistance can be solved in terms of your electrical. Um, it's not terms of electrical, it's the way of electrical actually. Okay, so that's what we will do here. That's the example that we have taken here. Okay, now we will take a problem here. I have inserted this problem here. Today is 10th, 10/09/2020. So this is a problem given here. Here you can see a composite wall. Okay, once we see a composite wall, what we should do is we have to look into its resistance circuit. Once we are in the position to draw its resistance circuit properly, you can solve the problem very easily. But before going into the resistance circuit, let me explain what is given in this problem. See, this is a composite wall, as you can see. Okay, this is one wall. A, this is completely A. This is one wall. Here you have B on top and the bottom. You have C, and this is D, and this is E. Yeah, all of you would join first, then you can keep changing the names. Right. Anyways, so this is one, this surface, this whole surface is calling it as one, and this surface is calling it as two. This surface, sorry, it's not two, it's two here. Here T1 on this side, T2 on the other side. So he's calling this surface as 1, this surface is 2. Let me call this as 3, 4, and 5. I'm giving it my own name for my own comfort. 1, 2, 3, 4, 5. And thermal conductivity of each thing is given. And what he's asking is, he's asking you to find what is Q. There is a heat transfer here. This is a one-dimensional case, and you will have Q. What is that? He is asking you to find. Also, he's asking you to find the temperatures of the intermediate walls. The intermediate walls are 3, 4, 5. T1, T2 are outer walls. The intermediate walls are 3, 4, 5. So what he's asking is, what is T3 value? What is T4 value? And what is T5 value? This is your question. So these four things, if you can find, you're done. So, but when you do any such sort of problem, I always suggest you to draw the resistance circuit properly. Once you are in the position to draw the resistance circuit properly, the problem will be very clear to you. Now, I'm drawing the resistance circuit here. I have A here. A will have a resistance. Okay, so and so thermal resistance it has, and let me call this as R A. And then I can see B and C. These B and C are parallel to each other and they are in series to A and D. So what I should do is I should draw a parallel circuit here. This should be a parallel circuit. Oh, yeah. Hmm. This parallel circuit, on the top you have RB, on the bottom you have RC. RC. Then again you have a resistance, and this resistance, let me call it as RD, and this RD in series with VNC, and then RE, which is in series again. So now, if I have to indicate the temperatures here, here you have T1, here you have T2, and then here I have T3, here I have T4, T5. So, T5. So these are all the temperatures and the resistances. Also, there is a direction for Q. So this will be your resistance diagram. Resistance diagram will be representing the resistances and the temperatures and the heat flow direction. Three things. One is resistance, two temperatures, three heat flow direction. So if you can represent all of them in this, that will be more than enough. Now, if I take the equivalent resistance of these two, it will be like this is RA, this is RBC, I will write. That is equivalent resistance of B and C, I'm writing. And then RD, RE. See, what I'm doing is I am simplifying my circuit to a series circuit. Here I have T3, here I have T4, here I have T5, and here I have T2. So this will have a direction Q. This is the direction. Now, my next job is to quantify these resistances. What is this RA? I have to find. The formula is L by KA. L corresponding to A, K corresponding to A corresponding to A. You have to take. That will be RA. Then RB. LB by KB into A. RC. LC by KC AC, RD, LC, LD, KD, EAD, RE is equal to LE by KE into A. Yeah, you have five things here. So all the resistance formulas I have written. Now, what is LA? LA is the thickness. The thickness of A is 5 centimeters. That is given here. So I'm substituting the same thing here in meters. So I have to multiply it with 10 to the power of minus 2. KA. KA is actually given in the problem. This is A, this is B, this is C, this is D, this is E. So Ka is 50. 50 watt per meter Kelvin. So I can substitute the value here. Now, what is the A here? A value, somebody should tell me. Okay, the A value is 1 meter square. It is given here. It is A area perpendicular to the direction of heat transfer. Q is flowing in this direction. The area perpendicular to this will be A. This A is 1 meter square. It is given. So you can substitute the value 1 directly. Okay. Sorry. Yeah, it's like one. Now, somebody tell me this value.
1 into 10 power minus
Sai Krishna, you tell me.
10 power minus 3.
10 power minus
10
3.
minus 3. How? What is the unit of this one? It is delta T by Q. So Kelvin per watt. That's what you will get. Now, let's move on to LB. Okay. LB, if we move on. Oh, what is the LB? The thickness is 10 centimeters. So I'll substitute 10 into 10 to the power of minus 2 on the top by K of B. K of B is given as 10 in the question. So I will substitute 10 here for KB. And the area, what is area here? This is the point to be noted. What is this area? Somebody tell me.
1 by 2.
It is 1 by 2. See, you can see this is made into two halves. Okay, this is A by 2 here. This is area by 2. This is remaining area by 2. So what I should take here is area perpendicular to direction of heat transfer. It is 1 by 2. So then you'll get some value. Somebody do it and tell me. Same is the case with your
0.02, sir.
0.02.
else this one, 0.02 Kelvin per watt. Good. So now LC is again 10 minus 2 by Kc. Kc is given in question as 6.67. 6.67 into what happened? 6.67 into the area again, it is 1 by 2. So somebody
0.
tell me this. 0,
0.029
029
Kelvin per
Kelvin
watt.
per watt. Good, good. You are done with your RA, RB, RD is also. You can calculate RD. You can see that this value is 5 centimeters here. So the 5 centimeters I will substitute here 5 into 10 to the power of minus 2 by KD. KD is given as 20. 20. Here you can see it. So 20 I can substitute. The area is anyways 1 here because the D is having the complete area. D is covering the complete area. So I can have 1 here. So I have the value here. Somebody tell me this value.
2.5 into 10 minus 3.
2.5 into 10 to the power of minus 3 Kelvin per watt. Good. Now, LE is again 5 centimeters. So 5 into 10 to the power of minus 2 by the KE. The KE value is given as 30 watt per meter Kelvin. So you can take it as 30. This is, sorry, 30 into 1. Somebody tell me this value.
1.66 into 10 power minus 3.
10 to the
Yeah,
power of
6 into
minus
minus 3.
Kelvin per watt. So good. We have found all the resistances now. Now that you are done with your resistances, you can move on to this equivalent resistance. You don't know RBC. You know every resistance in this circuit, but in this circuit, you don't know what is RBC. Now let us find out what is RBC. To find out RBC, so what you should do is a resistance in series concept. You have to take, sorry, resistance in parallel concept. Resistance in parallel concept, if I take 1 by RBC is equal to 1 by RB plus 1 by RC. So RBC will be equal to RB into RC by RB plus R. What's happening? RB plus RC. That is equal to RB value is 0.02. Am I right? RC value 0.029
9.
by 0.02 plus 0.029. Somebody tell me this RBC value now.
0.0118.
0.118 Kelvin per watt. This is your RBC. Now that you have this, right, this is your resistance circuit. Let me take this resistance circuit, put it at the bottom again. Control. Yeah, here it is. Yeah, this is what the diagram is. We have RA, RBC, RD, RE with you. He's asking you to find this Q. You know that this Q is equal to the temperature difference by the sum of the resistances. Q is equal to delta T by R total. It is simply delta T by R total. By definition, this is what Q is. So delta T is T1 minus T2 by the resistances in between. If I'm taking this minus this, I have to take sum of all these resistances. So it is RA plus RBC plus RD plus RE. So do you know T1? Yes, you know it. It is given as 800 minus T2, you know it, it is given as 100 by the RA value.
Sir,
The
can we change it
800,
to Kelvin?
800 and 100, you can see it here. See, you need not take it in Kelvin here. Even if you take it plus 273 here, minus 273 here, both will get cancelled. Whether you take it, you don't take it, doesn't matter here. Because you're taking the difference, it doesn't make any difference. Okay? So you're taking the minus of minus. So plus 273 minus 273 will get cancelled. So somebody tell me REA value. REA value is 0.01. Am I right? Is it 0.01? Yeah, it is 10 to the power of minus 3. 10 to the power of minus 3 itself here. But RBC is 0.011, right? 0.011. That is RBC. What is RD? 2.5 into 10 to the power of minus 3 plus 1.67 into 10 to the power of minus 10 to the power of minus 3. See, to solve this equation, you must have calculator with you. So I hope all of you are having calculators with you and solving it along with me. See, please have your calculators with you. Solve it along with me. That will be more than enough for your preparation. So if you do it along with me, you'll have more clarity. So now, somebody tell me what is the value of Q?
43.2 kilowatt.
43.2 kilowatt, you are saying?
Yes, sir.
43.2 kilowatt. Okay. First, you tell me what's 43?
41,249.26.
41,000 to
240.26.
49.26 watts. Good. So this will be 41.24 kilowatts. As you can see here, the numerator is in Kelvin and the denominator is in Kelvin per watt. Kelvin get cancelled and watt remains in the watt. You got it here. So if you take it kilo, you get a point over here. Okay, so this guy, right? So that's your Q. You're done with it. So what else he is asking you to find? He's also asking you to find what is T3, what is T4, and what is T5. Along with this, you have to find this one also. See, again, looking at your resistance circuit. Let me take this resistance circuit again. This resistance circuit, let me put it here. Yeah, from this resistance circuit, what you have written is, you have written that Q is equal to delta T by R total. See, previously what you have taken is T1 minus T2 by all the sum you have taken. Now I will not take like that. What I will do is I take T1 and T5 I will take by only these three will get. In between 1 and 5, I have RA, RBC, RB. So what I get is RA plus RBC plus RD. See, if you take this equation, Q is equal to T1 minus T5. T1 you know, T5 you don't know, RA, RBC, RD, all you know except T5, you can find out what is T5. So it's like that. And if you move on, the same concept delta T by R total I will use to write that. Q will be equal to, let me write it at the top so that you can see the circuit. See, one more Q, what I can write here is T1 minus T4, I can write T1 minus T4 delta T, and the corresponding resistances are RA plus RBC. So in this equation, only T4 is unknown. You can find out. Move on to the next Q. Let me write it as T1 minus T3 by RA. Only one resistance you will have here. In between these two, only one resistance is prevailing. So only that resistance you will have in the R total. So you're done. So if you use this equation, you can find out what is T5. If you use this, you can find what is T4. If you use this, you can find what is T3. Is it clear? So I hope you can find all of them. Please substitute and let me know
So
what
shall
are
we
the
take Q
values.
in watts?
Of course, you have to take it in watts because resistance is not in Kelvin
Kilowatt.
per kilowatt. It is in
Okay.
Kelvin per watt. So you
Okay.
have to take this Q in 41249.26. You have to take it in watts itself. 41249 is equal to 9.26 is also there. 0.26 is equal to the delta T. T1, if I take, it is 800 minus T5, I don't know. The RA value is 10 to the power minus 3. The RBC is 0.0188, 1188. 118 plus RD. I
So
should take,
T5 is 168.8.
yeah, this implies T5 is 168,
8.
yeah,
8.
8,
Yes, sir. 8.
8
0.888.
degrees,
Yeah.
0.8,
Yes, sir.
0.88 degrees centigrade. Is this the value? Somebody cross check with him.
Yes, sir.
R2. Is it
168.5.
168.5? Okay, good. So the same thing you can use for the next expression for finding T4, that is 800 minus T4 by 10 to the power of minus 3 plus 0.118. 018. That will be T4. Move on to the next one, 4124.9.26. 800 minus T3 by 10 to the power of minus 3 will give you T3. Somebody tell me the value of T4 and the T3.
22.1.
What? T4.
22.1.
Your voice is not clear. 381 is saying something. This
So
voice is
T
not
sir,
loud.
T4 is 272.272.
2 point.
That's it, sir. 0, 0.
This is definitely a wrong answer.
271.
This is 271 will also be mostly a wrong answer. Check this T5 also, somebody. I'm doubtful about even T5. Somebody please cross check.
Sir, T for 272.
Somebody is writing in chat also.
T for 27. T
T4
for 272, sir.
272, ah?
Sir,
See, is this correct? First, tell me what is T5.
T3 758.75 degrees.
T3 is
758.75 degrees centigrade.
so this is making some problem for me. Give me a minute. Give me a minute. I'll be back. Yeah, somebody tell me. This two.
72.00. 22.
Okay. This T3.
758.7.
758.73 degrees. Okay. Fine. See, what is T3
75, sir.
here? 7 3 years. This one, 7 5. Somebody say.
Ah, sir. T3, sir. T3, T3.
Yeah, 7 3 7 5 doesn't make much difference. Okay, it is
Zero,
precise.
zero.
See here, whatever the values you get, they should follow some trend. See, T1, if you have here, the T1 is 800, isn't it? It is 800 T1. And the TA should drop. It is around 7, something. You got, tell me what is that value? What is T3 value that you got?
158.76.
7?
158.7.
Good. What is this value? T4
270,
value.
2.0.
272.00.
40, na?
Double zero
Zero.
nine.
Okay. This one?
169.
58. Point.
One. And this one?
100.
100. See, the point here I want to emphasize is there is constant temperature drop. Okay. Whatever the values that you get here now, they should be in this range. Okay, they should follow this trend. Many people while solving it, they get some different values here which will not follow this trend. Okay, here there is a temperature drop in this direction. It is 800 here, it is 100 here. So all the values that you get in between should be in between 800 and 100, and the order should be as it is. Okay, order should be also like dropping direction. Somewhere you will have rise, somewhere you will have drop. This should not be there. So there should be constant temperature drop, as you can see here. Okay, is it clear? So is this problem clear
Yes,
to
sir.
you?
Clear.
Actually, Duke, you have asked some questions yesterday. Uh, Duke, are you there?
Yes, sir.
Is it clear, this particular question to you?
Ah, yes, sir.
I hope the yesterday's concept also will be clear now,
Okay,
isn't
sir.
it?
Yes, sir.
That problem and this one are same almost.
Okay, sir.
Right. This is just a practical application of what we have seen in the last class. Now, let me take one more question here. This question is similar to this one we have solved. So since we have less time, I'll just give you a clue how to solve it and solve it for yourself. Okay, I'll share this maybe on your WhatsApp group. You can look into this problem and then solve for yourself. Here, again, it is a similar kind of a problem. Okay, this is a similar problem where you have more layers of composite polymer. Here, you have few more complication compared to your previous case. This is also a simple case. What you have to do is you have to draw the resistance circuit for this case. When I draw the resistance circuit for this case, first A is there, RA, and then three resistances are there, RC is there in the top, and then RB on the next level, and then RC on the bottom again. So these three are parallel. And then, sorry, I should write D and E. Again, they are in parallel. So I have shown them on my parallel circuit. And then these two are in series with RF. So this is the thing. You have the temperature here and here. It is T1 given as 300 degrees centigrade. Let me call this T2 given as what? 100 degrees centigrade. 100 degrees centigrade. So this is what you have. And here the temperature, let me call it as T3 here. Let me call it as T4. Let me call this as T5. And in this question, what he's asking you to do is he's asking you to find what is Q. See, what you have to do is when you get a problem of composite wall, for that matter, composite cylinder or composite sphere, also the same story you will have. First thing is you have to draw the resistance circuit. Once you draw the resistance circuit, you will be in position to indicate what are the resistances. After indicating the resistances, you have to indicate the temperatures. After temperatures, you have to indicate the heat flow direction. So these three things you have indicated here. The simplified form of this, now I will write here. I will convert this parallel also into series, taking the equivalent. Right? So this is how it will be. Now here T1, this will be RA, this will be RCVC. I will write because C on the top, B in between, and C again on the bottom. So that's why I'm writing RCVC and then RDE, this one, D on the top, E on the bottom, RF here, and then here T2. I will write. This is T3, T4, T5, and then this will be your heat transfer direction. Three things you have shown, and then what you will have is you have to find out RA, which is LA by KA into AA. So you do it for yourself. I'm not going to solve it fully here. RC LB by, sorry, it's not B. Okay, LB and LC are SC, AC, AC, and RD, LD by KD to DAD, LD by KE. Likewise, you can write for F also. RF is equal to LF by KF into AF. And what I have to take here is areas. Okay, the area story is important here. Okay, for A, let me write the areas alone here. Areas are the things that should be considered very clearly here. Let me write them. Tell me, somebody tell me what is area? A, if I have to write.
Sir, it is a cuboid, no, sir.
It is cuboid, obviously.
Okay, okay.
So what is the area? Somebody tell me. For A case, I have to take wall A, I have to take area. Somebody please tell me this.
64 into
8 into this value. Okay, 8 into this area perpendicular to the direction of heat transfer. So the area here, I'm writing just AA values here. The remaining things you can substitute for yourself. 8 meters into 6 plus 6 is 12, or 4 into 3 is 12. Only one thing you have to make. So 12 into 10 to the power of minus 2. I can substitute here. So that area will get here. So if I have to get it for RB here, AB will be equal to 8 meters, and it's the same. This RB is 4. Only 4 is there. So I have to take 4 into 10 to the power of minus 2 meter. So this will be the same area for AC also. AB is having the same. And then A, C is done. Then AB, I should look. AD is 8 meters into 6. I have to write 6 into 10 to the power of minus 2. So likewise, you have to do it for E also. E also will be the same. The AF will be same as this. So I'll post this question in your WhatsApp group, or you can take a snapshot of this one right now. You can solve for yourself. Okay, same concept like here, previous thing. Q you have to find in the first place. Then you have to find out the temperatures. He's asking the temperature at this point where BDE meet. BDE is meeting here. So this wall temperature you have to find. Okay. Same thing. Temperature drop across the section F. So what is the delta T in this? Okay, in the next class, I'll ask you this. Maybe I'll share the solution. Right. So that's all for today from my side.